So now that we have an idea of how, or sort of like the components of the lac operon, now we know this is going to be the 3' to 5' template DNA, and it's going to have the promoter region, some genes, it's going to have the regulatory genes, it's going to have those structural genes. So now how does this work? So as I mentioned before, that lactose is what's involved in starting it. So if there's a present of lactose is going to turn it on. But the first thing that we got to do before we look at how lactose turns it on is let's just see how it works when there's no lactose present. So in this case, if there's no lactose present, then transcription should be off. So the first thing that's going to happen every time is that this repressor I is going to be made. So if we think about repressor I, it's constitutive, and what constitutive means is that it's always going to be made. So here we're going to draw our, we're going to have our lac I is going to make our repressor. So in this case, we have our repressor. Oh, come on, repressor. Let's hit, oh, we just made it big repressor. There we go. We have our repressor, it's made. So repressor I is constitutive, mean that the repressor is going to be made. Okay. So then what happens is the repressor's job is that it wants to bind the operator. Our repressor is going to go and bind the operator. So because it's present, it's going to want to jump over and bind the operator. So we're going to have it go here. It's binding the operator region, and it's actually kind of cool because you see it blocks this promoter arrow that usually means it's turned on. So once it's blocked like that, then our RNA polymerase, which the next thing that's supposed to happen is that it blocks it. It blocks it. So repressor I is going to block our RNA polymerase from binding. So here's going to be our RNA polymerase. RNA polymerase can't bind because of our repressor is in that space. So let's just make sure I show, draw, there we go. I'm going to show that it blocks it, so it totally blocks it there, and it keeps that RNA polymerase from binding, which means that if it's bound, it means that it is transcription off. So I'll type here transcription off. Okay, and that's what we're seeing here. So again, let's go through that. Make sure you just highlight this back up. Okay, so here, first thing that happens with no lactose, we have the repressor I that's made, which means repressor I is constitutive, always made. Repressor I's job is that it wants to bind onto our space here. So we're going to show it binding to our operator, which it did here. Binds our operator. If it binds to the operator, then we have RNA polymerase that's trying to bind that promoter region of PLAC, and it doesn't. When it doesn't bind, then that means transcription is off. When transcription is off, that's what 4 here says. It says transcription off means that no polycistronic mRNA is made, so no beta-galactosidase is made, no permease, and no acetyltransferase. So none of these get made.